So we're going to do some elimination today. What does it mean to eliminate something?
Yeah, take it away.
Like completely get rid of it, right? It's gone. And so if you can focus on that part, we're not substituting right now. Well, you will substitute at some point, but the initial step is to get rid of an entire variable. Like you want to figure out how can you cancel a variable out so that all you're left is with one, and then you can find the answer and then substitute back in. So our goal, it's been the same goal since we started this. Find an ordered pair that works for both equations. Right, so again, that's that ordered pair where the two lines would intersect. It's the ordered pair where the x and the y will make both equations true. Substitute them in. So great. Okay, so we're going to start out pretty simple, and then it's going to obviously get more complicated as we go along. But I don't want to scare you first thing. So we're just going to do some examples. This time, well, no, I'll just copy it down. Okay, does everybody have that written down? All right, so pencils down, look, listen, learn, so you can see what's happening before you write, and then you lose a step and you never pick it back up again. It happens. All right, so we're not going to get a variable by itself. That's not our goal because we don't want to keep any variables. We need to eliminate a variable. So this is going to turn into an addition problem. Okay, so we're going to combine top to bottom. Notice that the x's are lined up and the y's are lined up and our constants are lined up, just hanging out by themselves. So what's 3x plus 3x? 6x. What's 1y minus 1y? Those are gone. We eliminated them. They cancel each other out. And then, what's 6 plus 0? And now I just solve for x. And I know that x equals 1. And then, to find the y, what will I do with that x value? I just pick one of these equations to put it back into. Doesn't matter which one. Just put it in there. So 3x plus y equals 6. 3 times 1 plus y equals 6. Y will equal 3. Because I subtract the 3 from both sides, right?
Can you write that down now?
Yes, you may write it down. Ta-da! That's the elimination method. Most people, this is their preferred method. Most people. Some people can never get away from graphing. Some people will only do substitution when given the chance. On the quiz, you'll have to show me you can do all three, but then there's going to be questions where it's like, pick your method. Like, just give me the solution. I don't care if you substitute. I'll give you graph paper if you want it, or you can use elimination. But I will need to know that you can do all three of them at some point on the quiz. Haven't decided if the quiz will be next week or not because you'll have no school Monday, normal Tuesday, late start Wednesday, and then NWEA on Thursday and Friday. So I don't know if I'll give it to you next week. It's looking like you guys want it next week. I can tell by Cece. She's like, yes, I definitely want. Okay. Let's move on to another example. Okay, so I'm going to set this up like an addition problem again, where I combine the terms that are lined up. If your variables are not lined up, that's going to be a step you need to do. You can't use elimination between an x and a y. 1x plus 1x, 2. Negative 2y plus 2y, gone. Those eliminated each other. And then negative 7 plus 5, negative 2.
Oh, whoops, sorry. I don't know why that was on.
Is that your alarm when you wake up?
I need my lunch money in my backpack.
But wait, is that what wakes you up in the morning?
Yeah.
That's amazing.
I know.
What song is it?
What were you
I can say one morning I was sleeping over and her alarm goes off. I'm like, what is playing? And I could not figure it out. And she was like sleeping, and then our other friend was sleeping. I was like, oh my god, what is it?
Why do I hear a stranger voice? So what song is it?
I don't know.
It's just a creepy guy saying good morning, sleepyhead?
No, it's like, it's like, it's confusing.
Does it change every often, or is it the same guy every morning?
It's the same thing. Well, it's like, it has like it's like an inside joke behind it, kind of.
Okay. You're not going to share the joke?
No.
Okay, all right. Fair enough. That's fine. You'd be surprised. Like, I have to. How many of you hit the snooze button in the morning?
Like
Okay.
7 times.
Snooze? So, what did you say?
My mom wakes me up.
I mean, that's fine. I wake my boys up, but they're younger. You might want to start using your own alarm, though.
Alarm clocks don't work because it just like, I don't hear it. Like, it makes its way to my dream. It's weird.
Okay. But before you go to college, you're going to have to figure out something that'll wake you up.
I can just tell my roommates too.
Nope, they will not. Nope, they will not. They will let you be late. You're going to have to figure it out. Yeah.
Or my mom can just call me. Oh wait, no, I'm looking at.
That might be part of your dream that your mom's calling you. Okay, so here we get x equals negative 1. And then I'm going to put that into one of the equations. I don't care which one you put it into. It's going to work no matter what. And so then, of course, your solution will be negative 1, 3. Everybody feeling pretty good about this? It's going to get harder now. It's not always going to be super nice, like, oh, look, there's a negative 2 and a positive 2. I can just, like, cancel those out. And then you're going to have to use some, like, mathing to modify an equation so that something does cancel out. This is where how your brain attacks it, how my brain attacks it may not be the same. As long as I can see what you did and you get the right answer, we're good. Okay? So let's look at this next example. Okay, so as you can see, none of these coefficients are going to cancel each other out if I were to combine these. So I have to multiply either the first equation or the second equation by something so that I can force one of the variables to cancel out. Okay? There's like several answers to this. There's so many ways you can attack this. So what you might be thinking might not be what I'm about ready to show you, and that's okay. So my brain says, all right, I'm going to get rid of the y's. So what would I have to have in front of this y so that it would cancel out? A negative 5. So I'm going to multiply this whole equation by negative 5. The entire thing. Yes, Lux.
Actually, that's negative. It looks like it's plus 5y.
Well, I multiplied the top one, so this is a negative 5y up here.
Oh, yeah.
This stayed the same. I didn't do anything to the other equation. Now, sometimes you'll have to modify both equations to get the coefficients to cancel out somehow. It's not often, but it does happen. So now I can work through this problem just like I did on the previous two. I'm going to have negative 9x. These are now gone, equals negative 18. X will be 2. And then I'm going to put that x value back into either of these original equations. It doesn't matter which one. And then you're going to get your y. What does that 2, 3 represent? What does this ordered pair mean?
That's the other pair that works with both equations.
It works for both equations, and then someone else said it's where they intersect, if I were to graph both of those lines, right? Both correct answers. Okay, here's another one. You're going to do this by yourself. Turn around and keep over your shoulders.
Oh, that was, I was supposed to multiply that by -5.
So this is actually going to be positive 6y. And that's going to be positive 6y. Oh, you know what? So this needs to be multiplied by -2. So then there's a -8, so you get,
Oh,
this would be a positive 6 and a negative 10. So this is actually supposed to be positive here. Pretty good. Fancy mathing. No, it's not. So what you have to do though is choose one of these to be positive and one of them to be negative, so that the y's cancel out. Right now you have negative here's the y. So I'm walking around, I've seen about 5 different ways to do this, and that's okay, because we're all going to look at the coefficients a little differently. Yes. Well, you know what? 3 times 8 is
Oh, I didn't change it back.
all right. So you're doing okay. That's a very easy mistake to make. Emma, were you able to follow along? Okay, do you have any questions or any papers? All right. Drum roll. Here we go. 2, 1. Yeah? Raise your hand if you did yours differently than me. If you're not, just raise your hand if yours does not look like mine. I mean, the answer does, but the actual, this step here was different than mine. Yeah?
I did it to the top.
Perfect. Yep. So when I'm grading your papers, I mean, as long as you use elimination, that's the first thing if it says to. I'm going to look and see if you got the solution right. If you did not, then I would go through and figure out where the breakdown was, okay? But once you get the hang of this, I promise you'll be like, oh, I got this. I know exactly what to look for. I'm going to multiply everything. Let's do a couple more examples. And then we'll have time for silent ball. Oh, this is a good one. This is a good one. You guys are going to like this. Man. What's different, Jackson? They're absolutely not in the right places. So you need to figure out which one you want to adapt. And then move around accordingly using inverse operations, right? So I'm going to move this one around so that it looks like this one, right? So I'm going to have to subtract this 4x over here and then shift everything down. So what I'm going to end up with is 4x plus 3y equals 14. Didn't touch that one. And then negative 4x plus 2y equals 6. You have to rearrange, right? Does everybody see how I just subtracted this over here? And now it's actually pretty easy to solve because my x's automatically cancel out. Last one, promise. Bless you. You guys want to try this alone? Yes?
We can get wrong. Yeah.
Okay, if you're not confident, put those flare pens away and use a pencil. You can try it, and then if you can go over it with your flare pen if you. Okay. All right, I'm going to freeze my screen. Going to have to do some putting them in order, and then you're going to have to do some changing the coefficients. You got this. This is the extreme elimination round. Just made that up. Kind of proud of it. Yes.
Is there a way that you could have 0 equals and then equation and then change it around again? Like, if I added 3y and then I did something else to the other side, is it okay if I have 0 equals for a second?
For a second, sure. It's like a placeholder.
Yeah.
Yeah. Go for it.
Are the x's always supposed to be the ones that cancel out?
Nope. You can cancel out x's, you can cancel out y's. Does not matter which one you cancel out. Just keep in mind which one it is so that when you put your solution together, you don't flip-flop the x and y. What'd you do?
No, not good. No, we didn't do anything.
What?
Wait, is it 1, 2?
Negative 1, 2. So, all right.
Oh no, that's what I had. That's what I had. I had negative 29. And I couldn't do
Okay, here we go.
Wait, I need a new piece of paper. I had to rewrite.
So, again, you might have approached this totally different, and that's fine as long as you got the right answer. That's what I'm looking for. So I rearranged the second equation. I just subtracted 4x over here and shifted everything down again.
That would have been so much easier.
I wasn't sure where you were going, but I mean,
I didn't know either.
you can do that. It's just, it could have worked out. You just never know. Okay, so then I wanted to cancel out my x's. So I multiplied the top equation by 4, and then I had to multiply the bottom equation by a negative 3 so that the x's would cancel out. Or you could have done the top one by negative 4, bottom one by, I mean, there's a couple different things. You could have gotten rid of the y's first. There's a lot of things you could have done differently here. So then when I do those distributions to every term, I end up with negative 11y equals negative 22. Yeah?
Yeah, I know.
Your brain's okay? Maybe kind of, sort of? Okay. Sorry, Eden. All right, you guys have been silent all class. Let's not ruin it by playing this game. It's called Silent Ball. It was very quiet today.